Hello everyone, welcome to the Decode with Pankaj. In today's video, we are going to solve the SPPU 2019 pattern, third year of AIML department MIDS question paper step by step with easy explanations and exam oriented answers. This video will help you understand important concepts, answer writing format, and how to score better marks in university exams. Since the complete paper is lengthy, so I have divided it into multiple parts. So this is part 1 of the MIDS question paper solution series. Keep your notebook ready and let's start solving with the paper. Question paper TE AIML. The first subject is machine intelligence and data science 2019 patterns. Okay, semester second third year. Okay, so let's start with this. The first question is, what are the assumptions of linear regression? Okay, so in which this is a for 6 marks question, so in which we get what is the assumption, after that why it is impacting the linear regression and their advantages and disadvantages. Okay, so for that let's get assumption of a linear regression. Okay, so first of all, linear regression is based on several important assumptions. If these assumptions are violated, the model may give incorrect, misleading results. Okay, so there is assumptions are multiple. So first is linearity. In linearity, the relationship between independent variable x and dependent variable y should be linear. This means y is equal to beta naught plus beta 1 x plus e. Okay, so x is here x is independent variable and y is dependent variable, e is error. Okay, so if the relationship is not linear, prediction will be inaccurate. The second point is independent of errors. The residuals errors should be independent of each other. No correlation between errors. Important in time series data. Violation leads to auto correlation problem. Okay, so in which the residual errors should be independent of each other because they don't depend on each other. Okay, so homoscedasticity means the constant variance. Okay, so the variance of errors should be constant across all level of x, means in which whenever we try to train our data in multiple times with multiple levels, that x mini x, so that's why it is a variance of error should be constant across all the x input. Okay, x1 x2 xi x2, that's it. If variance is changes, then heteroscedasticity, and if the variance should be constant, then homoscedasticity. Okay, this affects model reliability. Next is normality of errors. The residuals should be normality distributed, help in hypothesis testing and confidence intervals, checked using histograms and QQ plot. Okay, the fifth is no multicollinearity. Independent variables should not be highly correlated with each other. High correlation means unstable coefficient, and unstable coefficients means no multicollinearity. Checking using VIF, variance inflation factor. Okay, so using this factor we check the multicollinearity. Okay, the sixth point is no measurement error in independent variable. So in previous we get the independence variable x should be measured accurately, so in which the error in x affect coefficient estimation. So that's why this is the overall assumption. The conclusion is, if this assumption hold true, the linear regression produces unbiased and reliable results. Unbiased mean without error, means they reduce the error and they get reliable results and impactful insights. Okay, so next question is, how do you interpret linear regression coefficients? Okay, so this is 6 mark question. So first is, what is linear regression? Linear regression it is a supervised machine learning model which deals with binary data and input. Okay, so in which we get only numerical continuous values. Okay, so like in linear regression we get the car price prediction, also plant disease rate prediction, also customer behavior analysis with price prediction. So overall the numerical data that we get in linear regression. So their equation is y is equal to beta naught plus beta 1 x1 plus beta 2 x2 plus So till plus e means here error, and beta naught and beta 1 it is a coefficients, and the x1 x2 it is our independent variables, okay, and y is our dependent variable, like y is our target value and it is our training data, okay. Each coefficient has specific value. Intercept b naught it is a intercept, okay. So value of dependent variable y when all independent variables is 0, then value of y. Example, base salary when experience is 0, okay. So second is slope coefficient b1 represents the change in dependent variable for 1 unit increases in x, keeping other variables constant. If example, if y is equal to 1000 plus 200x, then increasing x by 1 increases y by 200, okay. So third is positive versus negative coefficient, in which positive coefficient means direct relationship with each other and negative means inverse relationship with each other, okay. So next is magnitude of coefficient. Magnitude of coefficient means larger value is tends to stronger impact on dependent variable, okay, and the smaller value then it is directly impact on weaker side of impact, okay. So that's right. The fifth point is multiple regression interpretation, in which each coefficient shows effect of one variable while keeping others is constant, okay. The sixth point is statistical significance, in which checked using p value. If p value is less than 0.05, then the coefficient is significant, okay. So the conclusion is coefficients explain how each feature influences the target variable, means how each feature is related or relate to the targeted variable y, okay. So the next question is, what is the difference between logistic regression and linear regression, okay. So in which we get this our diagram, the feature, linear regression, logistic regression, okay. So in which first is linear regression. The purpose of linear regression is predict continuous values, and the purpose of logistic regression is predict categorical outcomes, okay. The output of linear regression is any real number, like any 1 2 0 1000, like price, okay. And the output of logistic regression is probability in 0 to 1 format, like binary classification, okay. So equation of linear regression is y is equal to beta naught plus beta 1 x, and equation of logistic regression uses sigmoid function, in which we get the multiple terms like back propagation, sigmoid function, and etc. It is also exist in the CNN, computational neural networks, and artificial neural networks. These terms of we studied that terms in this particular ANN subject, okay. So function used in linear regression is linear function, like in which we get the equation is y is equal to mx plus c, in which m is our intercept, c is our coefficient, okay. So that's why linear function. And the function used in logistic regression is sigmoid function, and the graph shape of linear regression is straight line, and the graph shape of logistic regression is S-shaped curve, okay. So in straight line we cover all the particular features in straight line, okay, relate with straight line, and in the logistic regression we get the S type of shape curve for the attaching all the features and variables, okay, all the data points on the plot, okay. So error matrix in linear regression is mean squared error, okay, MSE, and the error matrix in logistic regression log loss cross entropy, okay. And the example of linear regression is predict the salary, like house price prediction, employee salary prediction. And the example of logistic regression is predict pass or fail, like 0 or 1. The example is heart disease prediction, like the person have heart disease, yes or no, okay. Same. And the sigmoid function, what is sigmoid function? Sigmoid function is a core logistic function. Sigmoid z is equal to 1 upon 1 plus e raised to the power minus z, okay. This converts the output into probability between 0 and 1, like whenever our models get the output is have some value, okay. So for that value or that particular continuous value, this sigmoid function is convert our answer or output in 0 and 1 format, like the probability format, okay. That's it. And the next question is question 2. What is maximum likelihood estimation and how does it relate to logistic regression, okay. So in which maximum likelihood estimate, MLE. Okay, so MLE is a statistical method used to estimate model parameters by maximizing the likelihood of observing the given data. Like it is a statistical method and used to estimate the model parameters, like multiple parameters we get, like parameters mean the features we get for training of model. Okay, so maximizing the likelihood of observing given data. It answers which parameter values makes the observed data most probable, which parameter is affecting the data highly impactful, and also we choose the parameter beta that maximize. Okay, so L of B is equal to P of data by B. This is our formula for maximum likelihood estimation. Okay, so likelihood in logistic regression. In logistic regression, the target variable is binary, 0 or 1. It gives the output in 0 or 1. We model the probability using the sigmoid function. Okay, so this is our sigmoid functions equation. Okay, so how MLE is applied. Okay, so for each observation, if y is equal to 1, the probability is P. Okay, and for y is equal to 0, the probability is 1 minus P. So using this, likelihood become L of B is equal to, like in this first formula, P data divided by B. So according to the LB is equal to our probability is y is equal to 0 for that this, and also this is using that formula. So we maximize the log likelihood for easier computation. Using in the same equation we will use the log. So that's why key insights is logistic regression does not use ordinary least square OLS, and it uses MLE because output is probabilistic, errors are not normally distributed, and the conclusion is MLE helps logistic regression find the best parameters that maximize the probability of correctly predicting class labels. Okay, so the next question is, how do you evaluate the performance of logistic regression model and what metrics are you used? Okay, so for that we get, since logistic regression is used for classification, we use classification metrics. Okay, classification metrics means the logistic regression means what? The logistic regression is the predicting the continuous value like yes, no in this format or 0-1 format. Okay, it is a probability based classification. So for that we use classification matrix. Okay, so classification in which first is confusion matrix. Confusion matrix, what is? It is a table comparing actual versus predicted values, in which we get predicted 1, predicted 0, and actual 1, actual 0. According to then we get the 4 values. First is truly positive, second is falsely negative, next is falsely positive, and last is truly negative. Okay, so next is accuracy. Accuracy measures all correctness, like overall how much our model is performing well. Okay, for that we get accuracy matrix. Okay, using accuracy matrix we get the efficiency of our model and how accurately or how correctly our model runs without the error. Okay, so that's why we use accuracy. So accuracy, formula of accuracy is equal to truly positive means TP plus TN divided by TP plus TN plus FN plus FP. Okay, means what? Accuracy is equal to truly positive plus truly negative divided by confusion matrix. Okay, the sum of confusion matrix. Okay, so it is measure all overall correctness, not reliable for imbalanced data. Like for the accuracy checking we get the balanced data and we get the overall well performed data. Okay, or clean data or labeled data. For precision, it is a precision. Okay, so precision's formula is TP divided by TP plus FE, means truly positive divided by truly positive plus falsely positive. How many predicted positives are actually correct? For that we get the precision. And recall means it is the sensitivity. Okay, recall is equal to truly positive divided by truly positive plus falsely negative, in which ability to detect actual positives. Okay, the next is F1 score. F1 score, what is F1 score? F1 score is a balance between precision and recall. It is a ratio that is defined using the balance between the precision and recall. Okay, so F1 is equal to 2 into precision into recall divided by precision plus recall. Okay, so next is ROC curve and AUC. ROC curve shows trade-off between true positive rate and false positive rate. And AUC, what is AUC? AUC is area under curve. Okay, so how much area that is spreaded or that is calculated the between the curves. Okay, so one is perfect model. If our AUC is 1, then our model is perfect model, and if AUC is equal to 0.5, then it is a random guessing. Okay, log loss is a cross entropy, measures how close predicted probabilities are to actual values. Lower value, better model. Okay, the conclusion is use multiple metrics, not just accuracy, to properly evaluate logistic regression performance. Okay, so next question is, how do you visualize the relationship between predictors and response in logistic regression? Okay, so for that we get visualization helps understand how predictors affect probability of outcomes. Okay, so visualization helps to understand how predictors affect the probability of outcome, in which we get multiple type of concept. The first is sigmoid curve. It is also known as probability curve. It shows relationship between x and probability of y. S-shaped curve between 0 and 1, because it is a logistic regression. So in previous question we get the difference between logistic regression and linear regression. So logistic regression use the S-shaped curve. Okay, so that's why we use here the S-shaped curve. So according to that, S-shaped curve between 0 and 1. So this is our formula of sigmoid curve. Using that we get the probability. It is used for understanding model behavior, identifying threshold regions. Okay, so next is scatter plot with logistic curve. So scatter plot, it is used for showing the relationship between two or more features according to the specific conditions. Okay, and it is also tells us the how our data points are spread according to that conditions. Okay, so this is plot the data points x versus y on x-axis and y-axis, overlay sigmoid curve. And the scatter plot with logistic curve shows class separation, decision boundary, and that's it. And the third is decision boundary and visualization. Okay, in 2D, like in 2 dimensions, like only length and width in a line separating classes. Okay, a line that's separating the classes. And in higher dimension like 3D, 4D, and up to the 4D, 10D. Okay, so in that we use the hyperplane. Hyperplane helps to understand the classification region. Okay, so it have multiple regions like up, down, side. Okay, so it is like 3D slide. Okay, like that. So next is odds and log odds plot. Okay, so odds and log odds plot is logistic regression is linear in log odds. Okay, so it is a formula for log odds, and plotting log odds versus x shows the straight line relationship, like linear regression type of linear relationship. Okay, so next is feature importance plot. Okay, so feature importance plot shows impact of each predictor. Okay, and based on coefficient and magnitude. Next is partial dependence plot, advanced. Okay, it is advanced concept. Okay, so according to that shows effect of one feature while keeping others is constant. Okay, it is show only effect on only one feature while keeping others is constant. That's it. So this was the end of part 1 of SPPU 2019 pattern third year AIML MIDS question paper solution. I hope this video help you understand the concepts of important answers clearly. In this next part, we will continue solving the remaining questions in detail. If you found this video useful, then like the video, subscribe to Decode with Pankaj, and press the bell icon for upcoming parts and more exam preparation content. Thank you for watching, and I will see you in part